In this video, let us learn about Laplace transform of periodic functions. So first let us see what is a periodic function. Suppose if you have a function f of t, this is the function, then f of t is said to be periodic with a period t, capital letter T, if it satisfies f of t plus nt is equal to f of t. So if you replace t by t plus nt, n is a positive integer. Then if you get the same function f of t, then we say that f is a periodic function with period t. For example, cos function, sine function, these are periodic with period 2 pi, because cos of 2 pi plus t is equal to cos t. Similarly, sine of 2 pi plus t equal to sine t. Not just 2 pi into n. Here also 2 pi n plus t equal to sine t. So these two functions are periodic function and they are periodic with period t. So periodic function means f of t plus nt equal to f of t. Or like this, f of t plus t equal to f of t. Then f of t plus 2t equal to f of t, f of t plus 3t equal to f of t, and so on. Such functions are called as periodic function. So if you have a periodic function, then Laplace transform of that periodic function is given by, if f of t is a periodic function, then Laplace transform of f of t is given by, I'll directly write the formula, 1 by 1 minus e power minus st, this is capital T here, integral from 0 to capital T, e to the power minus st f of t into dt. The definition of Laplace transform had 0 to infinity. Now here 0 to t, the period of the function, then 1 by 1 minus e power minus s capital T, period of the function. Here small t is the variable, e power minus st f of t into dt. This is how to find out the Laplace transform of a periodic function. Let us illustrate this with an example. See, consider this problem. If f of t equal to t square and f of t plus 2 equal to f of t for all t greater than 2, you have to find the Laplace transform of f of t. See, it is nowhere given it is a periodic function, but this condition says that f is periodic with the period 2 here. So f of t plus nt equal to f of t means then f is a periodic function with period t. So here capital T equal to 2, f is a periodic function. Okay. So if f is periodic function, then what is the formula to find Laplace transform of f of t? 1 by 1 minus e power minus st, integral from 0 to t, e power minus st into f of t into dt. Let us first simplify this integral. So integral from 0 to 2, okay, I am writing here simplification of this integral, e power minus st f of t is t square into dt. So here you can apply either Bernoulli integration or integration by parts. You can use Bernoulli integration rule to integrate this by parts. So this is u, this is v. What is Bernoulli's rule? Integral u v dt equal to u v1 minus u dash v2 plus u double dash v3 minus so on. Alternative plus and minus v1, v2 are integrals, successive integration, u dash, u double dash, successive differentiation. This is the first function, this is second function. So this gives you t square here u into v1. So t square into what is integral of e power minus st? E power minus st by minus s. Okay, minus u dash 2t. Derivative of u is derivative of t square, which is 2t, into e power minus st divided by minus s into minus s, that is s square, then plus 2 into v3 here, e power minus st divided by minus s cube, then derivative of 2 is 0, so you can leave that term. Therefore, I got this value. You have to substitute that here now. This is 1 by 1 minus e power minus s into t means 2. Capital T means period. Period is 2. So, minus 2 s. Integral from 0 to t. See, we have to apply this integral also. 0 to t, limits 0 to 2. Okay. So once you apply the limits here, so now let us apply the limit. Upper limit is 2 here. 2 square is 4 minus 4 by s into e power minus 2s. Lower limit 0. 0 into any value it is 0. Next here, upper limit 2 2s are 4 into e power minus 2s divided by here s square. Okay, then lower limit t here 0, so that becomes 0. Then here minus 2 by s cube into 2 by s cube into here upper limit e power minus 2s, lower limit e power 0 means it is 1. So this is the final answer. So that we have to substitute here. That is minus 4 by s into e power minus 2s minus 4e minus 2s by s square minus 2e power minus 2s by s cube minus of minus plus 1 by s cube. Let us further simplify this. This is 2. It was 2 into e to the power minus st divided by minus s cube. So I had taken minus 2 by s cube outside. Then we had applied the upper limit and lower limit here. That is e power minus 2s divided minus e power 0 is 1. So this 2 comes for this also, minus of minus plus 2 by s cube. Now let me take this 2 by s cube outside. 2 by s cube into 1 minus e power minus 2s. So what remains here? 1. Then minus. Let me take e power minus 2s outside because that is there in every these terms, every term here. So here remains 2s square plus 2s plus 1. So that is because, look here, we have taken s cube as LCM. Here you have to multiply it by s square. So it is 2s square. Then minus is also taken outside. So all positive here. Here it is 2 into 1, 2 taken outside. Remaining is 1, 2. So 2 into s. Then plus 2 is taken outside, s cube is also taken outside, e power minus 2s taken outside here, so plus 1. So when you simplify all this, you will get the final answer as 2 by s cube into 1 minus e power minus 2s into 1 minus 2s square plus 2s plus 1 into e power minus 2s. This is the Laplace transform of the given periodic function. So, if a function is periodic with a period capital T, this is the formula to calculate the Laplace transform of such a periodic function. And this is an example to illustrate this. I hope you understood. Thank you for watching.